Today are going to graph absolute value and quadratic inequalities. So we're just graphing absolute value functions and quadratic functions. And then what's different with the inequality part is the shading. Okay, and then also keeping in mind when we want a dashed line or a solid line. So similar ideas to what we learned yesterday. That when it's just less than or just greater than, we'll graph using a dotted or dashed line. When it's or equal to, we use a solid line just like we normally use for graphs. Then, just like we've been doing with the other inequalities, we'll pick a point, ideally 0, 0, to test where we want to shade, and then there's going to be some shading involved. Now, because the graphs of absolute values and quadratics are not lines, the shading looks a little bit different here. Okay, so what we're going to end up doing with the shading is we either shade the outside of the function. Okay, this is me just kind of making up language, so outside of function. So we're coloring around that V shape, or we're shading the inside of the function. And it all is dependent on where 0, 0 is. Okay, so when we test 0, 0, just like what we did yesterday, if it's true, we want to shade the part that has 0, 0. So whether that's on the inside of the absolute value or the outside. And then the same concept applies to the quadratic graphs, where we'll either shade on the outside of the function or the inside of the function. And it's all dependent on where 0, 0 is. Okay, so again, when 0, 0 works, we shade the part that has 0, 0. When it doesn't work, we'll shade the part that does not include 0, 0. All right, well, once you've written down what the outside and inside function, what I'm referring to there, go and flip this page over. We really don't have that many examples to go through today, and we'll probably do it just like what we did yesterday, where I will do the first one, and then I'll have you all do the second one on your own. Okay, so again, the recognition piece, still want us thinking about that, even though we know this is only absolute value or quadratic. When I see you all on Monday, it's going to be all of these combined. So we'll have to continue to work on what type of function do we see. So absolute value function here with the vertex at 4, negative 5. Okay, so the x-coordinate 4, I am always switching that sign. With the y-coordinate coming after the absolute value brackets here, I leave that one as is. Then the a value is 2. So I'm going to go right 4, and then down 5. And then because of the shading here, we're going to use that a value that helps us get our next set of points over and over again until this graph takes up the entire coordinate plane that we have here. So up 2 over 1, up 2 over 1. I'm just going to keep on going and go the other way. All right, and before we connect our points, this is where we should start paying attention to what the inequality symbol is. With it being just greater than, we're going to use a dashed line. Okay, or a dotted line. And really with how we kind of plotted these points, with me using this marker, it's essentially already dotted. And I'm doing the dashed. And now we want to figure out where to shade. And I'll be maybe a little bit more explicit about the shading here because I think that's the place that we're most confused about. So here's what we're trying to figure out. Do we want to shade the inside of the V or the outside? And we're going to use this point here at 0, 0 to help us make that decision. Okay, so I'm noticing that 0, 0 right now is on the outside, or what I would consider the outside of this graph. And so if it works, I'm going to shade the outside here. If it doesn't work, then I'm going to shade the inside part. So we're going to test 0, 0, and that space underneath the graph. We've got lots of room to work there. So we're checking if 0 is greater than 2 times 0 minus 4 minus 5. Oh, and this brings up a good reminder about doing order of operations that involve absolute value, because I still need to do what's inside the parentheses there. So 0 minus 4. And 0 minus 4 is negative 4. But remember, I need to take the absolute value of that negative 4, which has me changing it to a positive. That's the only time that we're making something positive because of the absolute value. That's when you're taking the absolute value of a number. So this is really 0 is greater than 2 times positive 4 minus 5. Well, that's 8 minus 5, which is 3. So we're asking if 0 is greater than 3. That's false. So what that tells me is this side that includes 0, 0 does not work. So we don't want to shade the outside. So we're going to do the opposite and shade the inside of this V. Okay, so same kind of idea for how we figured out where to shade with the solving of inequalities, where if it works, we shade the side that includes our test point. If it doesn't work, we'll shade the other part that does not include the test point. Okay. So again, I'm going to ask that you all come back and do number 2 in a second, and I don't want you just doing it right away. I'm going to give you time to do it. Still want to keep our focus with the examples I'm going through here. So let's look at number 3 here. Once again, I'm recognizing that this is an absolute value function. I see the brackets here. Okay, the vertex here, the x is negative 2. I always switch the sign there. The y coordinate this time, because it shows up on the side with the y, I'm going to keep that sign, or I switch that sign as well. So that's going to be a negative 4. So this is the case where we actually switch the coordinates on the y. Then the a value is negative 1/3, which is essentially our slope. Yeah, thank you. I said switch the sign, and I did not switch the sign. So we want that to be a positive 4. Thank you for telling me before I actually put it on the graph and messed it all up. So again, yeah, that sign was opposite. All right, so I'm going to plot that point, negative 2 and then 4. And then using the slope of negative 1/3, I'm going to go down 1 and over 3 in both directions. Down 1, right, 1, 2, 3. Left 1, 2. Okay, and then let's keep using that slope so it spans the entire graph here. And down 1, left 1, 2, 3. All right, and then after we have the points, this is where we want to pay attention to the inequality symbol now. And because of this symbol having the or equal to part, we're going to make this line solid. And what we're signaling with the solid line is the points that are on this line also make this inequality true. So it's essentially like the coloring in includes the line as well. When it's dashed and we're coloring in, we're stopping as soon as we get to the dashed line part. Okay, so the points on this graph would make the inequality true. So now, again, where are we going to shade? Well, 0, 0. This time is on the inside, right? It's kind of in the middle of this V here. So we're either shading kind of below this absolute value graph, or the outside would be above it here. Once again, we're going to test 0, 0. So 0 minus 4, is it less than or equal to negative 1/3 times 0 plus 2, or the absolute value of? 0 minus 4 is negative 4. Then I have negative 1/3. 0 plus 2 is 2. Taking the absolute value of 2 has it staying as a positive 2. We don't switch the sign. Okay, we make it positive. If I had a calculator, I'd multiply these, and now it's going to tell me that it's negative 0.66. Okay, so negative 4, is that less than or equal to negative 0.66? That is true. Okay, -4 is more negative than -0.66, and thus we want to shade the part that has 0, 0, which I would consider is the inside of this absolute value graph. Here below the V here. Okay. Any questions here? Okay. On these last two examples, really kind of pay attention and think about where were we having troubles yesterday. Maybe it was with the graphs. Okay, with these being different graphs, obviously, comparing it to how you graph the linear is going to be a little bit different. But if that's something that you're having trouble with, really focus on kind of how I'm going about the graph here. If it's the shading, okay, really think about how I'm deciding how to shade one side of these graphs as opposed to the other. Okay, so two more examples here, and I'll have you all do the last four on your own. All right, number 5. I see the exponent of 2 telling me that this is a quadratic. The vertex here, I identify the same way as to how I did in number 3. The x-coordinate in parentheses, that sign's always opposite. It's +2. The y-coordinate here, I need to switch the sign, which I'm going to actually do this time. Make that -4. Then the a value is -1. So we'll plot our vertex going right 2 and down 4. And then remember, with quadratics, we use our a value the first time exactly as we see it. So I'm going to go down 1, over 1 in both directions. But then I need to multiply that a value by 3. 3 times -1 is -3. So my next set of points, I'm going to go down 1, 2, 3, and over 1 in both directions. When I connect all these points here, because of the or equal to, I'm going to connect them in a way so that the line is solid. And then once again, we're going to use that test point of 0, 0 to decide, are we going to shade the outside of this quadratic graph, which is most of the graph we have here, or are we going to shade the inside part of this graph? So just like before, let's test 0, 0. So 0 plus 4 is that less than or equal to -0 minus 2 squared. And when I'm doing the testing here, I'm going through order of operations, okay, and I'm not moving anything across the inequality symbol. On the left side, 0 plus 4 is just 4. On the right side, I need to do the parentheses first. 0 minus 2 is -2, and that still needs to be squared. Okay, so I'm going to square it and then multiply it by -1. So -2 squared is a +4, but then times the -1 makes it a -4. So we're checking to see if 4 is less than or equal to -4. And that's false. Right? 4 is greater than -4. Okay, so that means this side of our graph that has 0, 0 does not make this inequality true. Okay, so I don't want to shade the outside part here. Rather, we're going to shade the inside part. And again, think about the shading including the actual line that we graphed. Okay, because of the or equal to and the solid line there. Okay. Questions here? All right, well, one last graph. And again, this is a good reminder from a previous lesson we've had not too long ago on how we graph a quadratic that is not in vertex form. Okay, when it's in standard form. So again, the recognition piece, I'm recognizing that it's a quadratic because of the exponent of 2, but right now I don't have all the information I need to be able to graph it. The one thing I can pick out is that A is 3, okay, A is 3, B is -18, and C is +18. And I'll need that A value, but I'm going to also need the vertex. So to find the vertex, we have to do that negative b over 2a. And again, anytime that you're using that, I'm going to recommend that you write that down. Okay, the more we write it down, the more we see it, the more we're going to, or the more chances we have of remembering that. So if b is negative 18, negative b is positive 18, then 2 times a, or 2 times 3 is 6. 18 divided by 6 is 3. Then to find the y, I need to plug 3 right back into the equation. And since I'm just using this x value of 3 to find y, again, I don't really care about the inequality part here. Okay, it's more just what y value do we get. So y is equal to 3 times 3 squared minus 18 times 3 plus 18. And just since we don't have a ton of space, I'm just going to let the calculator do the work for me. Again, if we're still having trouble kind of getting to the right y value with the calculator, these are things we should be asking about, but also things that we're practicing, okay, because it is a skill and not the most obvious. All right, so here we go. I'm going to take 3, open parenthesis 3, then the squaring. This is the subtraction button of 18, and then parentheses 3, so times 3, and then plus 18. And I get negative 9. So a is 3, the vertex is at 3, negative 9. So let's plot that, 3, negative 9. Then the a value of 3, I'm going to go up 3 and over 1. 1, 2, 3. And then 3 times our a value is 9. So from those last 2 points, I'm now going to go up 9 and over 1 in both directions. Okay, so up 9, we're already at 6, so 9 will get us to 3. And this time, we're going to connect these points using a dashed line. And now we need to figure out where to shade. Okay, so this time 0, 0 is on the outside of this graph. Let's see what happens when we plug in 0, 0. So 0 is at less than 3 times 0 squared minus 18 times 0 plus 18. This works out really nice, right? All these zeros kind of go away. And so we really just have 0 being less than 18, which is true. So since this is true, we want to shade the outside of this quadratic graph. And that includes this right side as well. Okay. The last 4, I'm going to ask that you all try on your own. I'm going to actually stop the video here.